It's Orkan. Welcome to my channel. Today we are going to solve a LeetCode 994 rotting oranges problem. So let's first look at the problem statement. The problem statement is that we are given m to n grid, and where each cell represents one of three values. Either it's 0, which representing empty cell, or 1, which is a fresh orange, and or 2, which represents rotten orange. So every minute, any fresh orange that is 4 directional adjacent to a rotten orange becomes rotten. So what's that mean? For example, let's take for this example. So in this example, we have only one orange that is rotten at the beginning. So every minute, oranges that are in 4 adjacent directions, which means that the up, down, forward, and back. So these directions, they become rotten also. And let's say that if these two rotten, so for example, first minute, these two become rotten, then the next minute, because of these two, this one and this one becomes rotten, and so on and so forth. So we need to, our goal is to return minimum number of minutes. So minimum number of minutes that we need in order to get the all so in order to have the all cells in all cells have the rotten oranges. If it's impossible, we are returning -1. So there are cases, for example, in this case, when it's impossible to have doesn't matter how many minutes pass, it's impossible to have all oranges rotten. So in that case, we are returning -1. Okay, that's the explanation. Let's see how we are going to solve this problem. Let's take actually one of the examples that we have seen before, maybe a bit modify that and work on that example. Let's say we have this grid 3 to 3, and at the start we have what we got here. We got, let's say here, rotten orange, and let's say that we have here rotten orange, and let's say that all others are, there is no empty cell, all other filled with the fresh oranges. So what we need to do, we need to calculate the smallest, the minimum amount of time that we need in order to make all of these cells, in order to have in all of these cells rotten oranges. So what we can do, so let's say that we are represented in some sort of structure. So let's say that at the beginning, what we got here, we got 2 rotten oranges. So we have here, let's say that this one and this one, let's say this one, let's just put the coordinates of this one. This is 0 and 0, and this one is 1. So here it's 1, and from here it's 2. Let's say 1 and 2, right? So we have this one. So what's going to happen? In the next minute, this is the starting point. This is the basically 0. So 0 minute, we just start here, right? So what's going to happen in the after 1 minute? 1 minute, every orange that is in that adjacent to this one. So there is no oranges here and here. There is no oranges here and here. But this one and this one, it will become rotten. So this one become rotten and this one becomes rotten, right? And so what we need to do? So we can, so it means that this one will become rotten and this one. So it's the coordinate of this one is 0 and 0 and 1, 0 and 1, right? And for this one is 1 and 0. So this one becomes 1 and 0, right? And the same for this one. So what's going to happen? So all adjacent to this one, they will become rotten. So this one and this one and this one. So like 3 coordinates, like this one, 3 here, 1, 2, and 3. So this one. So this is the first minute. What's going to happen if, let's say that it's not 3 to 3, right? It's, let's say, I don't know, like 50 to 50. What's going to happen the next minute? The next minute is whatever adjacent to this one. So maximum there could be like a possible, let's say that the 4 cases, right? 1 or 4 adjacent. Let's say that all of them were fresh, and we are all of them were fresh, and like we are making them rotten. So this is the second minute, and so on. So it looks like a graph, right? So we are representing it in a graph. And what we need to do, so we are going layer by layer. So first, in the first layer, 0 minute, we are adding only these 2 that are rotten. And the next, like a first minute, so here we just starting position. So we just 0. So on when we start, there are 2 cells where the oranges are rotten, so we are adding them. So the first minute, so this one becomes rotten, so these 2 and these 3 becomes rotten, so we are adding them. And the next minute we are adding whatever adjacent to them, and after that whatever adjacent to this one, and so on and so forth. So let's say this will be 3 minute, 4, and so on. So this is a graph, and what we need to do, we need to do a level order traversal. So we are going to use breadth first search algorithm. So and we are going to go layer by layer, and for each layer we are going to increase 1 minute, and at the end we are going to check that if there is any fresh orange left. If there is any fresh orange left, then in that case we are returning -1. Otherwise we are returning the time that it took to make the all oranges in the grid rotten. All right, that's the explanation part, and now let's go to the coding part. Right. So first thing that we are going to do, we are going to create time, which we are going to return as a result. So just let's return that time. After that, what we need to do, first thing we need to do, we need to check or go over our two-dimensional array, and we need to check we need to find all our rotten oranges and add to the queue. So for that, let's first create a queue, because we are using BFS, and for BFS we need to maintain a queue. So for that, let's create a queue, right? And which is gonna take our we're gonna take our array, and let's just call it simple queue, and let's initialize it. It's linked list, right? So let's now go over our two-dimensional array and define the all rotten oranges. So for that, I is less than, take the first x-axis. So for that we need to take the grid length, and plus plus. So the next one is that we need to take the x-axis. So for that, int j is equals to 0, grid I, so grid 0 length. And j, so yeah, let's check if grid ij. So basically we are going over every cell and checking that is there any rotten orange. So I and the j, right? So we are checking if it equals to 2, which means that it's rotten. If it's rotten, then we are adding that to our queue. Let's push to our queue. So we are gonna create a new int, and for values we are gonna pass I and the j. All right. Okay, so the first part is done. So we added them to the queue, and now we need to go layer by layer and make the in the first, let's say that the 1 minute passed, and we making all the oranges that that is adjacent to the one that is already rotten, make them also rotten. So for that, what we are gonna do, we are gonna go over our queue. So we are gonna just basically we are implementing BFS. So until it's not empty, what we are gonna do, first thing that let's take each and every one of them. So for that, let's just call size and queue size, right? So for that, let's go for int I is equals to 0, I is less than size. So basically we are going over every rotten tomato, and we are taking every rotten tomato. So and the I++. So what we are doing here, we are first of all taking it int let's just call it current, and we are queue, we are pulling that from the queue. So if we are basically taking that from the queue, and what we are going to do with that, we need to, so we have the rotten tomato now, and we need to check that in 4 dimensions, whatever is adjacent to that, if it's fresh, then we are going to make it rotten. So for that, let's create, so how we are going to go in 4 directions. In order to go to the 4 directions, so basically what we need to do, we need to make like a 0. So let's say that if it's 0 and 0, right? So how it should be 1 and 0, then it should be -1 to the other side, right? -1 and 0, -1 and 0. Then the next direction that we need to check is 0 and 1, and in the x-axis, right? And 0 and the -1. So 0 and -1. 0 and -1. So this is all possible cases. In order to mimic that, we are going to create an so we are going to create here the integer that we are going to call directions, array of integer. Let's just call them directions. And so new int, and we are gonna mimic the case that I explained below. So we are gonna take them 0, 1. We can make it longer, but to make it short, we are gonna use this this approach. So 0 and 0. 0, 1, yeah, 0, -1, 0, yeah. So so what we're gonna do, let's create one method. Let's call it check coordinates. check coordinates. So what it's gonna take? It's gonna take our current int, right? Our current cell. Let's just call it current. It's gonna take our directions, and let's create a method here. So so what it's gonna take? It's gonna take our current, it's gonna take our directions, and it's gonna take our, so it's gonna take our directions, and it's gonna take our Q. And it's gonna take our Q. So what we are gonna do here? So we are gonna check that the int j is equals to 0, and the j is less than directions length, and j plus plus. So what we are gonna do here? So we are gonna take that as basically we are gonna mimic this scenario when we are like 0 for the 0, 0 coordinates. So we're gonna take 0, 1, so 1, 0, and minus 1, 0. So to mimic that, so we are gonna say that it's let's call it int x, and it's gonna be our current 0, so the first coordinate, plus directions j, right? And the same one here, y, and 1, j plus 1. So basically we are mimicking all scenarios. For example, in the first one we are going 0 and 1, we are going on the axis, so on the x-axis up. Then in the next one we are going on the x-axis to the right, and so on. So we have these directions. Now what we need to do, we need to check that if it's in that directions, so we need to check that in our grid, right? So yeah, also we need to pass our grid here. So we need to pass our grid here. We need to check that if it's in our grid, whether in our grid it's it is whether in our grid it's fresh orange. If it's a fresh orange, then we are gonna make it rotten. So for that we are gonna call this one, right? And check coordinates. So we are gonna pass there, what we are gonna pass? We are gonna directions grid, and we are gonna pass Q. And also we are gonna pass our current coordinate, the new coordinate that we have, which is, let's create new int, and x and y, all right? So we are gonna pass it. So here what we need to do, we need to check that our int x is equals to current 0, and y is equals to 1, right? Okay. Now we need to check in our grid if, yeah, it's not returning anything. Let's just put the void. So if our grid x and y, if it's equals to 1, right, 1, which means it's fresh, then in that case we need to add to our queue, add our new int x. Yeah, we can actually just add current here. Okay, so we are adding our current, but another thing that we need to check, so for example, if it will be like a -1, then we need to check those corner cases. X should be more than or equals to 0. The same with the y. The same with the y, and also we need to check that they are not going over the grid. So for that, x should be more than grid length, and also y, so less than grid length, and also y should be less than grid length. Okay, so yeah, let's put here and so after passing all these scenarios, like x more than or equals to 0, y is more than or equals to 0, x is less than grid length, which means that we are not going over the length of the grid, and in the y-axis also the same. If it satisfies all these conditions, then we are checking. If it's 1, then we are then what we do, we are adding our current to the queue. But before that, let's also in the grid mark it as x and y. Let's mark it as equals to 2, because at the end we're gonna check the grid one more time. Right, so yeah, that's it. Then if we are checking that, so we are adding that to the queue. The next thing that so we checked all the coordinate, we added to the queue, and once we exit this for loop, so it means that it means that the first layer is completed. If the first layer is completed, then we are checking that if our queue is not empty, so which means that we are going to go to the next layer, then in that case we are going to just increment time. And after so that's it for the BFS part. After completing the BFS part, what we need to do, we need to go over our queue one more time here after completing everything. So we need to go over one more time, and we need to check that if there is any so we need to check that one more time, that if there is anything that is fresh still, like let's say that we went into because we are going into in for only checking like only making it rotten, that is in x and y dimensions, right? Let's say that the something that is adjacent on the other side, they are still fresh, and we haven't covered those cases. So that's still there's a possibility. So fresh oranges may still be in the grid. So because we are going up and down, left and right, but whatever is let's say that on the let's say that the one, right, whatever is in the near the one, we are not covering those cases. So if at the end it turns out that there's still fresh orange, then we are returning -1. If it's not, then we are just returning at the end time. I think that's it. It's pretty long, actually. It's pretty long explanation, but let's run this scenario. Hopefully it will pass from the first time. Okay, check coordinates. Let me see, Q directions. Okay, Q, I am passing here, create directions. Okay, let me see one more time. Let's see, check coordinates. Check coordinates. We are passing int. We are passing directions. We are passing grid, and we are passing Q, right? Should be okay. Oh. Yeah, let me check. Oh, here for int j. Yeah, like I forgot to put j. J is less than yeah, grid length. The same here. The same actually here at the end when we are checking. J is less than. So let's check one more time. Yeah, let's make it add. Okay, so here yeah, it's -1 actually. All right. If it is not empty. Good. All right. Okay, let's run. Okay, great. It works as expected. Yeah, let's go over it one more time. So what we did here. So first thing that we did, actually, as I already explained in the explanation part, we first thing that we are doing, we are finding all possible cases when the orange is rotten. So we are finding that, and we are adding that to our queue. Then the next, we are implementing BFS. So basically we are checking for every case. So for example, let's say first layer, right? We took like 2 elements, and for those 2 elements, when the oranges are rotten, we are checking that in the x-axis and in the y-axis, we are checking that the whether or not it is there is a fresh orange. If it's a fresh, we are checking the corner cases, because it should not go over the grid, like on the left side and on the right side for X and for the Y. After making sure that it's within the grid, we are checking if it's fresh. If it's fresh, we are adding to the queue, and we are going to the next layer. So before going to the next layer, we are checking that is there anything that if the queue is empty, which means that we are not going to the next layer, so we should not increment the time. If it's not empty, then we are incrementing the time, and at the end, once we visited all the cells, we are checking one more time whether there is a fresh orange or not, because there might be cases when let's say, for example, right, like this one is 0 0, this one is 0 0, and the one is below that is 0 minus 1, 0 minus 1. The one that is above is 0 1. The one that is on the right is 1 0, and the one that is on the left minus 1 and 0, right? But there are cases, let's say, that we are not checking the one that is 1 and 1. For example, for this particular scenario, right, we are not checking that. And there might be cases when this one is still fresh, and we went, let's say, we did not make it. We will make it for this one. We will make it fresh. We will make it rotten in the next iteration. But there might be cases when it left out. If it's left out, then if it's left out, then we are returning -1. Otherwise, if there is no fresh oranges left, we are returning time that it took to make the all oranges rotten. And that's it. It's a pretty long explanation and a pretty long code. So hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.